In this video, we are talking about Minterm expansion, a way that enable us that go from truth table to the circuit design. We are claiming that we only need AND or and NOT gates to compute anything. It means that we build a circuit that implements any binary function. Let's consider this truth table. We are saying that this truth table produces 1 as output in two scenarios. The first scenario, x is 0 and y is 1, and the second one, x is 1 and y is 0. For each of the rows that produce the output of 1, we can build an AND circuit that produces the output 1 and works only for a specific input. For this example, for the red row, we can build an AND gate with feeding negate of x and y to it. And also for the blue row, because x is 1 and y is 0, we can feed x and negate of y to the AND gate. At the end, with feeding the output of these two ANDs into an OR operator, we can produce the output. The question is, do we have to handle the rows with 0 as output? The answer is no, because with adding more zeros to an OR gate, the results does not gonna change. Here it is an example from the previous video. We can summarize the truth table by a Boolean expression. In a Boolean expression, the line over the x or x bar represents the NOT operator, the plus represents OR, and two values that are adjacent to each other represent the AND operator between these two values. This Boolean expression is called Minterm expansion of the truth table, because one minterm for each row represent the output of 1, and combining these using OR, we can reach out to the output. So if we recall the procedure for building a circuit, the first step is to specify the truth table. Then using the Minterm expansion, we can design the circuit by considering building an AND gate for all rows that produce 1 and OR all them together. Here it is an example. Let's assume our function has 3 inputs, and this is the output. At first, we need to delete the rows that produce 0 as an output. For the remaining rows, we need to build a minterm for each row. If a variable has a value as 1 in that row, we wrote its name. If the variable has value of 0, we need to negate this 0 into 1, therefore we need to use negation. And we can AND all these variables to create our minterm. For instance, what is the minterm for this function? For the first row, because x and y both are 0, we can write down as x bar, y bar, and z as the minterm. And with ORing all these minterms together, we can produce the output. So for this function, the first minterm is x bar, y bar, z. The next one, because y has value 1 and x and z both has value of 0, so we need to negate x and z and we leave the y as it is. With applying the same principle, we can write down 4 Minterm expansions for this function. Using Minterm expansions, we can build the circuit. For this example, you can see Minterm A, B, C, and D, and you can see Minterm A, B, C, and D as the AND gates, and the output of these using an OR produced output of the function. We can see that each Minterm, because it is designed for a specific input, is actually an input selector. Here it is another example. The odd parity function is a function that produces 1 if the number of ones in input is 1. We can see that on the output is that the output is 1 if the number of ones is odd. We can write down its Minterm expansion and then convert it to a circuit. Recall that we can build any function using Minterm expansion and 3 AND, OR, and NOT gates. Thank you for watching this